Let's discuss the terminologies related to arithmetic progressions. But before that, let me quickly define an AP or an arithmetic progression for you. It's a sequence in which the difference between any two consecutive terms is constant. Examples like a list of natural numbers, right? Now, let's look at this sequence. In the context of this sequence, we'll understand what the terminologies are. 2, 4, 6, 8, and so on. Now here, the difference between any two consecutive numbers is constant. That is 2. You can see that. So it is definitely an AP. Now, 2, 4, 6, 8, these are all known as the terms of the sequence. So the first term is 2, second term is 4, third term is 6, and so on. Now, if we have to write a general term of an AP, we denote it by AN. So for the first term, N becomes 1. So A1 is the first term. For the second term, N becomes 2. So A2 is the second term, and so on. So in our example, A1, the first term, is 2, A2 is 4, A3 is 6, and A4 is 8. You know something? The first term, that is A1, is generally denoted as A. So if you have A, that means it is the first term. Now in our example here, we can write AN or the general term as 2 into N. So A1, the first term will be 2 into 1, that is 2. A2, the second term will be 2 into 2, that is 4, and so on. To identify an AP, we always find the difference, I've told you that, between two subsequent terms. And this difference is known as common difference. So between second and first term, A2 minus A, the difference is called common difference, denoted by D. And this would obviously be equal to A3 minus A2 or A4 minus A3 as well. Now in the example that we've taken, what is the value of D? Right, it is 2. Look at this general formula. Yes, you can use it to find the common difference D. It is AN, that is the nth term, minus AN minus 1, that is the n minus 1th term. Let's go back to our example. 2, 4, 6, 8, so on. You see those dots? What do they signify? Yes, this AP does not end. So you can't find the last term. And since it does not end, obviously it is known as an infinite AP. But if I remove those dots, that means this AP has only these 4 terms, 2, 4, 6, and 8. So it becomes a finite AP. And this time we have a last term, that is 8. And this last term is denoted by L. Let me quickly give you one more example of an AP. You see those fractions? So what if they are fractions? They still form an AP. The first term is 3 by 2. So A is 3 by 2. And the common difference D is second term minus the first term, 5 by 2 minus 3 by 2, or 2 by 2, which is 1. So when you work with problems on arithmetic progression, you will deal with formulas, and those formulas will have these terminologies. So know them well.